memory analysis with volatility. I'm going to caveat this talk by saying that this is the type of talk where we realized at the beginning of the week that we didn't have a second speaker. And I said, all right, I'll do something. Then I realized this morning that I didn't have anything to present. So this was written this afternoon, so first off, I apologize if for the content, because the content is not the way that I would like it. It's mostly just walls of text, so I will apologize for that now. However, most of it is going to be demos, so hopefully that will make up for that. And the great thing is with and get all the magic information. Consultant for CoreLogic Security, and I do a lot around malware analysis, reverse engineering, and incident response. And with incident response, you inevitably will come into doing memory analysis. So why? Why memory analysis? When you look at the way that traditional forensics works, it's looking at in quotes, dead space. You're looking at disk images of disks that aren't running. You know, you've taken an image of the disk and you're looking at what happened on the disk. You're looking at timestamps. You're looking at what files exist. You're pulling the registry and events off from the files themselves and converting them into readable format and looking at them. You're doing reverse engineering. You know, when you're doing reverse engineering, most of the time you're not doing this on a live running executable. When you get into debugging, you do, but with reverse engineering and disassemblers and decompilers, you're looking at the dead code listing or the assembler of the file that you're looking at. But this only gets you so far. In a compromise, attackers use the system. They get on the system, they compromise the system, and they leave traces behind. Sometimes these traces can be found in the traditional forensics. Looking at a timeline, for example, of all the different time changes on a Windows server, you can sometimes get a pretty good idea of what they did. They executed this command, and then they wrote this file, and then they wrote to this registry entry, and so on. But you don't get a clear. You don't always get a 100% clear picture. You don't necessarily see what they typed. You don't see what the program that they ran, what it was. Sometimes, if they securely delete the program after they use it, you're out of luck. You can't recover it. You can't see what it was. Plus, when a computer is shut down, a lot of these traces are gone. So let's say a attacker got onto a system and connected out to a website. Let's pretend that you don't have proxy servers, you don't have firewalls, or they're not logging properly, you don't have IDS to pick up this traffic. You will never know that that server went out to that, or that malicious program went out, or that attacker went out to that server. There are some things that may leave traces behind. The Internet Explorer cache files, the history, they may leave some information behind. But if it's a direct socket connection, you're never going to know that. As soon as that computer gets shut down, that's wiped from memory. It's not going to be on disk. You're not going to be able to find that. So this is why memory analysis is so important. With memory analysis, we can look at the memory of what is running on a computer and pull out that information as to the sockets or the network connections that we're connected to, the processes that came and went. If somebody has loaded a rootkit, you can even use memory analysis to detect that rootkit and to detect the things that they're hiding. A lot of times, live response toolkits, these are the triage toolkits that you'll run on a system to grab some of this volatile information, will get these, but they'll also miss things as well. If the things are hidden, for example, with a rootkit, then your live response toolkit may not be able to grab that information because it's running on the compromised system. It's at the mercy of what the kernel tells it, and if the kernel has a rootkit in it, then you're out of luck. If you're doing a memory analysis where you've dumped memory and you're looking at the raw memory itself, you may be able to pull this information out. So with memory analysis, inevitably you have to talk about how do you dump memory. I'm not really going to talk about this too much, except to say that there are a lot of really great free tools out there to do this. There are some commercial tools as well. I have not found a commercial tool. I have not found something that a commercial tool does that I can't find for a free tool that's out there. The good news is if you have a virtual machine, it may automatically do it for you. So VMware, when you hit pause on a VM image, it actually dumps the memory to a .vmem file, and you can actually load that into memory analysis programs. It's the raw memory. It may have a little bit of a header on it, but it is the raw memory. VirtualBox, there's a way to do it as well. And VirtualBox is a little bit more difficult, but it is possible to do. These are a couple other tools that I've personally used to dump memory. MDD, Dumpit, FTK Imager, WinPMem. These are all free tools. Yes?
So what's your preference out of the tools you show?
I actually use FTK Imager more than any other tool. And I'll show it in a second. I don't like it because it's GUI, and because it's a GUI program, it means it's going to be modifying a lot more stuff than a command line program will be in memory or on a system. But I've never had it fail for me. All these other programs, you need to look at their specs to see what operating systems they support and what service packs they support and what architecture they support. Because some of these may only support up to Windows Vista 32-bit, Service Pack 2. Some of them may go all the way up to Windows 7 or Windows 8. So you really want to make sure of that. I prefer, like I said, I prefer FTK Imager, but that's just a preference of mine. I also use, I've also used Dumpit for scripting because it's a command line tool. So in some of my scripts, I use Dumpit, although that has failed on me more times than FTK Imager has. Kind of leads to the next thing. When do you dump memory? As soon as you can. Once you get on a system, you want to dump memory first. If you're going to do memory analysis, dump it first before you run any of your other tools. The reason you want to do this in this order, or dump the memory first, is because if you start running a bunch of tools, you're going to be modifying memory, you're going to be knocking things out of memory, you have the potential to lose information, or you just have the potential to have more stuff that you have to go through from the tools that you ran. By running your memory dumping tool first, you're going to have that memory in a more pristine condition than otherwise. I will say the tools have to be run with administrator access. So just keep that in mind if you're doing response. If the ID that you're logged in as does not have administrator access, you probably won't be able to dump memory. Or if you are able to, you won't be able to get everything. Yes?
Is there a difference between domain and local admin?
I'm going to say yes. So the question was, is there a difference between local and domain admin? You need to have local administrative rights to that computer. If you're logged in as a domain admin and they don't have local admin rights to that system, then you probably won't be able to dump memory. Also, when you dump memory, it's going to create a file. Understand that this file could be huge. If you're on a system that has 512 meg of memory, no big deal. You have a 512 meg file. If you're on a system that has 12 gigs of memory, you're going to have at least a 12 gigabyte file. So when you dump memory, first off, you want to make sure that wherever you're dumping it off to, you have enough disk space to put it there. None of these tools, to my knowledge, and I'm probably wrong, but none of the tools compress memory as they dump it. So they're going to be dumping if you have 12 gigs of RAM, it's going to dump a 12 gig file, and then afterwards you can compress it. Now, if you're going to be doing a disk image of this system, you obviously don't want to be dumping this onto that disk because you've just wiped out 12 gigabytes of disk space, which could have data in it that you wanted to see. So typically, it's a good idea to put the memory dump off system. I typically use like a flash drive or something that has enough space on it to put it on there, or to put the file on. In other cases, I've mapped the drive and have done it over the network. Obviously, that's a lot slower if you're transferring gigabytes of information, but it's not on the system. I do want to say too, no matter what you do on a system, it's going to change the system. You're on the system itself, this is a compromised system. You want to keep everything as pristine as possible, but no matter what happens, it's going to be changing information and data on the system. So you want to minimize those changes as much as possible, which is why this is the order that we recommend. So just to show you how one works really fast, hopefully this will work. So this is FTK Imager. This is a free tool. And it can actually do disk images as well. But for this one, it's pretty easy. You just do capture memory. You tell it where it wants to go. In this case, I should have like a map drive, maybe. Well, that's resolving. This particular VM has a gig of memory. So here we go. I'm just going to dump it over to the shared drive. Click capture memory, and it's going. I mean, for a VM with a gig of memory, it actually goes pretty quickly. Obviously, you're going to be limited by the there's nothing running on the system right now. This is a Windows 7 box. There's nothing running on it now, so there's no performance hit. But if you have a server that has a database and a web server running on it still, obviously that's going to slow you down a little bit. But I'm already done.
Are any of these tools flagged by antivirus at all?
I have not had any of them flagged by antivirus or get stopped because of antivirus. I will say, though, that in my live response toolkits that I use, we have stuff in there to shut down common antiviruses before we start our tools. These could, that's a good point. These could look, if your antivirus has like a host IPS on it or like heuristics in it, it may see this as a tool that looks malicious because it's trying to get at the low levels of the kernel and dump memory from there. I'm pretty sure that most of these tools have to load a driver in order to work. So, that could look malicious. So dumping memory can be that simple. Right. Let me get back to my slides. All right. So volatility. Volatility is an open source free framework designed for memory analysis. It doesn't dump memory, it analyzes the memory for you. This is my opinion up there. It is the only memory analysis toolkit that you should ever need. I have looked at commercial memory analysis toolkits. The ones that I've looked at don't even come close to what Volatility has. Now, what I will say is it's solely command line based. So if you're not comfortable at the command line, then you're not going to be comfortable with Volatility. But it is very actively developed. In fact, in 2 or 3 weeks, they are having their second user conference. And it's just a whole day. They're actually having pre-conference training on how to develop in Volatility, how to develop your own plugins, how to do analysis, and then a whole day of talks. So it's still very, very actively developed. This is the URL for it, volatilesystems.com, or their Google code repository is volatility.googlecode.com. If you don't write those down, just Google memory analysis and Volatility, and it'll be the first hit that comes up. So the big thing about Volatility is the memory images that it supports. What can it look like? Because every different version of Windows and every different service pack within Windows changes the kernel structures and the memory structures just slightly enough that one version is incompatible to another. So in Volatility can support, for Windows 32 and 64-bit architectures, XP Service Pack 1 and 2, Vista Service Pack 0 through 2, 2003 Service Pack 0 through 2, 7 Service Pack 0 and 1, 2008 Release Candidate 2, and Service Pack 1 and 2. So pretty much all of the operating systems that we'll probably want to look at. It also supports Mac OS X images, Linux images, and Android ARM memory images. So if you can dump memory from any of those devices, there are going to be Volatility plugins that will allow you to look at the memory or analyze the memory. The Windows plugins are definitely a lot more Windows plugins than there are Mac, Linux, or Android plugins, but they're at least there so you could fool around with them and get some information out. Memory can be read in a number of formats. Typically, it's read raw, meaning it's just a direct dump of memory. But there are also a number of other formats that it can read, like HPAC, which is I think it's done by HP Gary's Fast Dump. It's memory dumping program. VMware, the .vmem files, it usually puts like a little header or something on the front of it. It can read those directly. VirtualBox files, it can read. It's crash dump files, it can read directly. There's about a dozen different memory formats that it can read. So it can read a lot of different things. The plugins, these are Python-based plugins that are used to perform the memory analysis tasks. So the way that Volatility works, and we'll see this in a couple minutes, is that when you run it, you give it a plugin to run. And each plugin does one thing. It's either going to pull out process information, or it's going to pull out networking information, or it's going to pull out handles, or it's going to dump a process from memory and onto disk, and so on. So each plugin does one thing, but it does it very, very well. As of the latest release, meaning this morning when I updated my source code, there were 169 plugins, and there are more floating around the internet. In fact, if you go to the Volatility Google Code site, their wiki has a lot of information, and they have links out to other non-supported plugins. In other words, plugins that other people have written that they just haven't included into their main body of code for whatever reason. Yes?
One thing I also make another tool that was a little more automated, read something.
I know what you're talking about. I think that's a Mandiant tool. Yeah, it was a Mandiant has also come out with their own tools to do memory analysis. I can't remember what they're called though. What is it? Redline. I think that's what it is. The only thing that I will give the Mandiant tools over Volatility is that the Mandiant tools can read in the hibernation files and the page files on a system. To my knowledge, Volatility cannot, or if it can, it doesn't take them in context with the memory as well. The Mandiant tools can do it, although compared to the Mandiant tools, Volatility is just way above. It's very funny. I guess it's not very funny, but it's kind of interesting that the guys who create Volatility do not get along with the memory guys at Mandiant. So much so that in order to register for Volatility's conference, you have to pre-register to them to make sure you're not employed by Mandiant. I mean, it is just some feud that's going on, but every once in a while you'll see one of the developers just make a snide comment about somebody else. It's kind of funny to watch, but anyways. Moving on. Back to the plugins. Not every plugin is going to support every memory profile or architecture. So you may have a plugin that only works with XP in 2003. It doesn't work with 7, 2008, and so on. The good thing about those specific plugins is usually there is another plugin for the architectures that are missing out of the first one. And I'll show you an example of that in a second. So to run Volatility, you download the archive, you install it, which is pretty simple. In fact, why not? So just to show you how easy it is to install. All right. Hopefully, can everybody see this? Good. Cool. All right. So this is just all this is the source code repository that I had updated earlier today. In order to build it, you just run. Again, I'm on Linux. I think it'll run on Windows. They have specific instructions on how to do it. You run Python setup .py build, goes through it, builds everything, and then to install it as root Python setup .py install. And my password. Take a second, and it's good. You're done. So it's now installed. Now, doing it this way, it only installs the Windows memory analysis stuff. There are some extra things that you need to do if you want to analyze Linux and Mac and Android memory images. Those are documented on their websites. It's basically just a couple other packages you need to install, some prerequisites.
Is that Python 2.7?
Yes, it is, Python 2.7. All right. So there are a couple, I guess, global options that I'll say for Volatility. First off, you run it by running the vol.py program. That's Volatility. If you give it --info, it's going to print all the available plugins, all the memory architectures, and global options that it has installed. If you give it the -h option without a plugin specified, It will show you basically put all the global options, basically options that you can give to any plugin, plus all of the plugins that you can run. There's a difference between -H and -info in that -info is going to show you everything that's installed, but not necessarily that you can run. -H is going to show you everything that you can run. You give it a -F and then a file name. This is the file containing the memory image. -S profile equals the memory profile to examine. Each memory image is a little bit different. So Windows XP Service Pack 0 32-bit is going to have a different profile than Windows 7 Service Pack whatever 64-bit. So you have to specify what it's looking at. It's usually pretty good at figuring it out on its own, but you can specify that just to shortcut some extra work. And then -V, you can usually give it a verbose mode just to spit out more information for you. So just to show quickly what some of this looks like. All right. So I'm going to run it with -info. Hopefully this will stop it. All right. So first off, it's showing you all the different profiles that it has. These are all the different Windows and Vista and all that. Scanner checks, honestly, this is kind of new to me. I've never used these, so I don't know what these exactly do. But I'm sure it's something cool that you can do with it. And then finally, plugins. Lots of different plugins. And finally, all these are the different memory formats that it can read. So lots of different information. That was -info. If I just do -H, these are all the global options that you can give it. And then finally, the supported plugins, the plugins that you can run right now. You'll notice that these are there are a lot less of these than with -info. You don't see the Linux ones, you don't see the Mac ones, because my machine isn't set up to do Linux or Mac memory analysis. All right, so there are a couple common plugins that you'll probably run off the bat most of the time. There are ones related to processes. These are the processes that are running or were running in memory on your system. There's PSList, which prints out all the running processes by following the eProcess list. So the way that Windows works, the Windows kernel works, is for processes, you have an object called _eProcess. This has all the information about the process. It links to all these other structures that contain like the name of the process, where it's coming from, where all the different memory trees are, and so on. And then the current running processes are created or are put together in this huge linked list called the eProcess list, which basically has things like, it's a linked list. It has a link to the current process and then a link to the next process. And so when you do something like Task Manager or you run Task List on Windows, basically what it's doing is it's finding this eProcess list and walking down the list. So this is going to show you all the currently running processes at the time that the memory dump was taken. Now, PSScan, this actually goes into memory and looks for the individual records themselves. So if a process had ended or had been unlinked, which is what a rootkit will do, it will hopefully find it. I will say that not every plugin is infallible. It will miss stuff. I've seen lots of different times where I would think that data would be there. I find it through another plugin, but it gets missed in another plugin. PSX View is really cool. It actually scans for processes using a number of different methods. The method that PSList does, PSScan, and then a couple other ways. And then it gives you basically this huge table that says, I found this process using this method, but not this method. So that could mean that there's a rootkit installed, that process could be hiding, or for some reason that memory or that technique didn't find that process. Finally, there's one called DLL list, which will give you a list of all the loaded DLLs, the dynamically linked libraries, for each process. That's usually good if you want to see what DLLs are loaded by a process, but the nice thing about this one too is it prints out the process command line. So you can see the command line options that were given to the process. I have not found a way in any of these other plugins to pull out that information. There are some network-related plugins. There's sockets, which prints a list of open sockets. You can think of this as the netstat of volatility. Sock scan, this is very similar to the way that PSList and PSScan worked. Sock scan basically just searches for all the different sockets that are in memory, whether or not they're linked in the kernel structures. Connections. Connections and NetScan are basically the same thing, except Connections will do it for XP in 2003, whereas NetScan does it for Vista 2008 and Windows 7. And finally, ConScan. This is like SockScan. It just starts looking for TCP connections in memory. There are some malware-related plugins if you're doing malware analysis or you suspect that there's malware on in the box that you're looking at. You can run malfind. This will go through and will find signatures of hidden and injected code, which will let you figure out whether or not something has injected code in it, which could indicate malware. API hooks. This will detect API hooks. I will say that the first two of these, if you run them, they may flag benign processes as suspicious. So things like drivers, especially like network drivers or some type of driver that inserts itself into somewhere, or antivirus, will often do things that look like malicious code. So these may flag benign processes as suspicious. You just have to take everything within context. Yes?
What is it doing when it's trying to find the injected code and you don't have a disk image compare on image versus on memory? What is it doing?
I don't know specifically what it's doing. The guy who wrote this, who wrote Malfind, I think his name is Michael Hale Lee. He's absolutely brilliant when it comes to memory analysis, and I think he has a pretty good white paper on what he does in this plugin. The nice thing about these being Python is that you can look directly at the code to see exactly what it's looking for. If I had to guess, it's either going to be looking for signatures of injected processes, so different memory segments that start or end with certain pieces of code, or I would think that there's probably a way to tell when a new memory segment has been created. It'll get its own memory space within the program, and it probably does some heuristics around that to figure that out. Beyond that, I honestly couldn't tell you without looking at the code or reading his stuff. Proc.exe dump is a great tool, or I'm sorry, a great plugin. We'll actually look at this in a second. It basically takes a process from memory and dumps it into an executable file. So in theory, you can take that, dump a process from memory, and then run it again. You can't always run it again, but I have been able to. If nothing else, dumping the process to an executable file allows you to load it into something like IDA Pro or do malware analysis on the file itself. DLL dump is very similar to proc.exe dump. It's going to basically dump every DLL that's loaded into a process to disk. And finally, Yara scan. If you're familiar with Yara, it's basically a signature finding tool. Think of it as Snort for disks or files. You can actually scan memory with Yara signatures. You can actually use memory analysis for penetration testing as well. We'll look at this in a second, but you can actually use it to dump passwords from memory, which is really cool to do. Why you would ever... I will admit that I don't necessarily know when you'd actually have to do that, dump them from memory, when you already have the memory image, because you have to have administrative rights to dump memory anyways. Now, I guess I can think of one or two weird situations, but you can do it. All right, so let's leave it at that. So, all right, so I'm going to jump into some examples. Are there any questions before I jump into them?
Great for unlocking a coworker's workstation.
All right, hey.
Are you speaking from experience?
I would never do that.
That's actually a good point. You can actually use memory, or I'm sorry, you can actually use volatility with some modifications to write to live memory as well. There are no free tools that I'm aware of that will allow you to mount memory on another system as a live, like a disk or a file. There are commercial tools that will allow you to do it, though. There's one which I can't believe I can't even remember its name right now, but it's a great tool, and it costs like $100 for an enterprise license. And it basically allows you to mount any disk or memory from over the network. I'll have to find it and put that in because it's an awesome tool. But anyways. All right, so just give me 1 second. All right, so let's pretend we have this situation. All right, where we've got this memory dump. All we've been told is that the system was acting funny. There were some IDS signatures going off. We need to look into it, and all they gave us was a memory dump, which actually happens every once in a while. So what we want to do is we want to figure out what we can about this memory dump. So the first thing we need to do is figure out what type of system we're dealing with. That is where the image info plugin comes in. So some of these plugins will take longer to run than others. Just keep that in mind. So here, what we found is that the profile is a Windows SP Service Pack 2 x86 box or Service Pack 3, one of the two. When I'm given a choice, I usually go with the higher Service Pack. Then it gives you some also other information, number of processors, when the image date and time was taken, so you can see when the image was created, and so on. So we know what the profile is, so we'll use that. So we know we're dealing with a Windows Service Pack 2 system. So first thing that we can do is, let's look at the network connections that were on the box. So I'm going to use the connections plugin. It's going to go through, and it dumps all the network connections that were happening at the time the memory dump was taken. So we've got two connections. One, this looks exactly like kind of what you would expect to see in NetSat. You've got the local address here, the local port, the remote address, and the remote port. To me, this first one probably isn't malicious. It's a 139 connection. It could be. We don't know. But this one over here, this 443 address, is kind of interesting. The PID is the process ID, so we're going to use this to figure out what processes these are. So, and I'm going through this kind of fast. Just keep in mind that I did all this morning, so I already have all the commands listed down. If you were going through this in incident response, you'd probably be looking at multiple pieces and kind of pulling data from everywhere. I'm purposely not doing some things because this is actually from a forensics challenge that's out there. It's the 2012 GERCON Forensics Challenge. There's a whole list of questions that you can go out and try this yourself. And there are a lot of different write-ups on how to do it as well. So I'm only going to go a little bit into this. So here we do the process list. It's kind of hard to see with this font, unfortunately. What we see here is we've got the offset, the memory offset, the process name, process ID, the parent process ID, number of threads, when it started, and then if it exited, when it exited. We have a couple processes here that have exited. This is a lot of information to look at. So let's only look at the processes that showed up in our connections. So if I'm correct, it was 4 and 1096. So now we only have to look at two processes. The first is the system process. This is where the port 139 connection was coming from. And then explorer.exe, where it was coming from the port 443 connection. The system one isn't necessarily suspicious. The Explorer one kind of is. You usually don't see a HTTPS connection coming from explorer.exe. We can do a little bit more. There's another plugin. I think it's called PS Tree. Cool. So it kind of gives you a tree view. And we can look. You see here's explorer.exe. System is where it should be at the very top. Explorer.exe is down here. Just looking at it off the top of my head, I can't tell you whether or not it should look like that, but at least this is just another view you can see it as. And then finally, I'll show you the other one that I talked about. That I think it was called PSX view. What was it called? Yeah, PSX view. You know what? Let me cancel that. for our 2 process it'll take. Yeah. All right, never mind. So this will go through, and this is going to look at all the different, use all these different ways to find processes, and hopefully it doesn't take long. It'll show us how many it found and so on. So there we go. So you can see that even with normal programs, you find that it doesn't show up in every single way. The time I would be suspicious, potentially, is that if it showed up in PSList, or I'm sorry, if it showed up in PSScan and not PSList. And we probably have a couple of those. Yeah, WinLogin, wherever that went to. So there are a couple. So that could mean that the process had already exited or it was being hidden, and we'd need to do further research in order to determine that. But at least we know one process that we want to look into a bit closer, the process 1096, which was supposedly Explorer.exe. So let's focus on 1096. And let's run malfind against it. This is the process or the plugin that looks at it looks for injected and hidden code. So here it's found some things. Again, this could be valid. It could not be. What we'd have to do is for each process that it pulls, it gives you the memory location of where this happened. And what we would need to do is we'd either need to recognize that this is malicious code, which I couldn't tell you just by looking at it, or we could dump the memory surrounding this address, see where it's located at, see how it came to be, just pull more information on it. Very rarely are you going to get information, just like with everything, very rarely are you going to get something which tells you this is malicious. Sometimes you do, but not necessarily. But we can see here that there's a whole bunch of things that it's flagging. And I would guess that if we would run this against a normal Explorer.exe, we would not find all of this happening. So to me, that just means that we are definitely dealing with something malicious. Another thing that we can look at for that process are mutexes. Does anybody know what a mutex is, or it's also called a mutant? No? All right, so a mutant or mutex is basically a memory locking structure within memory, within a program. It's often used by malware to prevent multiple copies of itself from running on a computer. So each mutex has its own name. It's assigned by the program that creates it. So a lot of times what malware will do is it will set up a unique mutex on the system. Let's say bad file is the name of the mutex, and it will set that up when it infects the system. And then if it gets infected by the same malware, the first thing it does is check for that mutex. And if it finds that mutex, it knows that it has already infected the system, and the second process can just kill itself. So a lot of malware will often have unique names for mutexes, and so it's often useful to go in and see what mutexes are running for a specific process. So we're looking at the Explorer.exe. Has a whole bunch that pull up. Does anything jump out to anybody?
Really scary thing you can't pronounce.
The fourth one down?
Details, fourth one down.
Does anybody recognize that? So if you would Google that, you would find out that that particular string is the default mutex name for a malware, a backdoor known as Poison Ivy. Anybody recognize? Everybody dealt with Poison Ivy before? All right. So when you create a Poison Ivy bot piece of malware, it's got a nice GUI interface. The default mutex is that string. For some reason, attackers don't ever change that. It's literally you click a button and it'll change it. They never do. I don't know why. But we can at least identify, and you'll never see this anywhere else. You may see it actually if you dump memory and doing a strings analysis. If you have antivirus running on the system, you may see that in antivirus, in the signatures for the antivirus. But you'll never see that string anywhere else, or you should never see this string. So with this, we can be fairly certain that what we're dealing with is a poison ivy infected system. Luckily, Volatility has some pretty cool poison ivy plugins. So there's one called Poison Ivy Config, which what it does is it will go through, you give it the process of the poison ivy. In this case, the process is 1096. Probably not explorer.exe. It's probably actually a poison ivy it probably is explorer.exe, but it's also probably had the code injected into it, which is probably the code that we saw with malfind. But its configuration is going to be somewhere in memory for that process. So we can use this plugin to hopefully dump the like this config. Cool. No crap. I swear this worked before. I know what's going on. Just give me 1 second. That's what happens when I. This is what happens when I install something after I've installed it and made sure that it worked. So there are a lot of contributed plugins. Poison Ivy one is one of them. So I'm just going to copy to where it should go. Cool. All right, so let's try this again. All right. I don't know why it's not working. Let me just look at one more thing. This. That's why. Cool. Finally. So here's the Poison Ivy configuration file. So Poison Ivy has this really huge configuration file that gets associated with it, that gets compiled into it. It gives you a lot of different information. So the interesting things that we can see here is, first we have the mutex. This is the mutex that we saw. The original file, this is the original file that it got loaded as. So the original file is /windows /system32 /svchosts.exe. On Windows, the program that you'll normally see is svchost.exe, no S at the end of it. Melt original file, this means that it deleted the original file. However, if we were doing disk forensics, we could go and look for prefetch files for this. We could go and look for any other indications that this file had executed. Here we've got this is great. We have the command and control server. This is where we saw the 443 connection to. Even better, we have the password for the command and control server. This is the password that Poison Ivy uses to log in. So, not that I would ever recommend doing this. If we wanted to, we could create our own Poison Ivy bot, install it in a sandbox, and allow it to connect out to the command and control server to see what the bad guy was going to do on our system. Would never recommend doing that, but you could do it. There's no keystroke logger. We see that it copied the file over to system32 /svchosts.exe, so for some reason it copied itself over to itself. And then we have some more information, like how it remains persistent in the system, and so on, and then the process that it found it in. So hey, so we found it in explorer.exe, which is what we expected. So we've got some pretty good information just from that. So we found the malware. You know, what else can we find? Just looking at some other Volatility plugins. There's one called Command Scan. This is going to search through looking for any command.exe processes, and it's going to actually pull out any commands that were running command.exe. So if your attacker used command.exe, you're going to find something. So in this case, we found, it's kind of hard to see, apologize. We found this first one up here. The first couple are cut off, but this is actually the responder doing the memory dump. They're using MDD. If you look up here, they mounted a file. Go down. Down here, you can see them FTPing the file, so they're probably FTPing to a server. So we could look to see if we own that server, if it was part of the IR response or something else. Then down here we have another one, a csrss.exe, where it caught some things as well, where somebody did a dir. It was just a bunch of different commands. So this may or may not be related to our attacker. There's another one that we can use, which is very similar to this, called consoles, which basically does the same thing, except you get to see everything that the bad guy saw, or whoever was at the command prompt saw. So here we have the command prompt starting. We see them do the net use, the response, the dir, the response, them doing MDD, and basically everything that they run. Fortunately, this is just from our responder who is dumping memory for us, so it doesn't give us any indication of what the attacker was, but you can see how this would be very useful. If you have an attacker who used a command prompt, you may be able to recover this information from memory. And then finally, let's look at the registry. So whenever you want to look at the registry, so let's say we want to look at the persistence mechanism, see if there are any other weird registry entries. You want to see where all the registry hives are in memory. The hive list plugin will show you that. We'll actually look at that in a second for a better thing to do. But let's say we wanted to look at the key Microsoft Windows current version run. This is where a lot of malware will put itself to persist. We can run it, and if it doesn't crash, we get everything that was set to run from within this key. The first two, we could do research, but this just means that Adobe was installed. The last one, we should recognize this file name. This is our malware. So this is how our malware is set to auto-start itself. There are a lot more things that you can do with this. Like I said, there's over 170 plugins. We've only looked at a couple for incident response. If you want to practice more like this, I really recommend going out and downloading the 2012 Gurkhan Network Forensics Challenge, because not only this is what we went through, but there's a list of about 24 questions that it wants you to answer. So not only are you directed as to what to look at and how to find it, there are lots of great write-ups out there on the internet on how people went through and did it. In fact, the guys who wrote Volatility went through and answered the questions and wrote how they did that. So I know I've been going for a while. I have two other quick ones to show. So here, let's say we were on a pen test and we were given this memory image, or we found this memory image for some reason somewhere, and we wanted to dump the hashes. So first, let's see what kind of memory image we're dealing with. This memory image is a gig, so it's a little bit bigger. So it's going to take a little bit longer for things to go through it. While it's running, does anybody have any questions? Mm-hmm. I've obviously done this before, so the most important thing here, we're dealing with Windows 7 Service Pack 1 and 0. I should say these memory images I've had, so it's not like I didn't create all of this today. I just kind of used what I had. So we're dealing with a Windows 7 box. We want to dump the hashes, but in order to do that, we need to find the memory offsets of the system and SAM hives. So that's what the plugin needs. So here we're going to use hive list. So system you can find here. Here's the system hive. This is the memory address. The SAM hive is down over here. So we're going to use the hash dump plugin. Actually, if you want to see the specific memory options, they're all here. Here you give -y for the system hive offset and -s for the SAM hive offset. But I wrote all those down. So I will say too, I have seen this not work before on different memory images. For some reason, it doesn't work very good on Windows XP, but Windows 7 it actually works pretty well. Knock on wood. There you go. So there we have the hashes dumped from memory. So we could load that into John the Ripper, our whatever GPU cracking system we have, and so on, and try to crack those. Finally, so I wanted to put this in here because I find this is how I use volatility the most. So when you're doing malware analysis, oftentimes malware will come packed. If you don't know what a packed program is or what a packer is, it's basically a program that's been compressed or encrypted in some way to basically hide the internals of the program. The point is, usually the point for malware to be packed is to hide it from analysts, make it harder to unpack, make it more difficult to analyze. So to give an example here, we've got, actually we have this malware here. One of the easiest ways that you can tell if malware is packed is by doing a strings analysis on it. If you don't see a lot of readable strings, in other words, strings that make sense to you, it's a good indication that we're dealing with packed malware. So here I'm just running strings on it. We see a couple here, but the rest of them are just basically garbage. None of these make sense to us. So let's say that it's packed. There are a lot of different ways that you can go through and pack and unpack executable sample. Usually, though, if you can't find a program that will unpack it for you, you're having to go through and do it manually in a debugger, which can be very difficult to do. It can be very time-consuming, and there are lots of different tricks that malware can easily put into itself to make your life a living hell when you're trying to unpack malware from memory. Fortunately, Volatility has made this extremely simple. So what you do is you take your malware that you can't unpack, you load it into a VM, you run the malware, and then you dump memory. So what's happening is when your malware is running in memory, it has unpacked itself. By definition, in order for it to run, it has to unpack. And so in memory, it's going to be unpacked. So we've dumped memory with our unpacked memory, or with our unpacked malware running in memory. So what we do is we just dump it from memory using Volatility. So just to show you which one it is, I lost my mouse. I'm just going to do a process listing. The malicious process is here, 1b.exe. I know it because I was running it. The process ID is 508. So what we're going to do is we're going to run the Proxy Dump plugin. We're going to tell it to dump process number 508. This is our malware process that was running in memory. And then the -d is basically where do you want it, what directory do you want to dump it to? I'm just telling it to dump it to the current directory. Take a second. It was able to dump it without a problem. And we now have a file called executable.508.exe. If you remember us doing the string search on the packed one, we didn't see a lot of strings in there. But if we do it on the unpacked one, or the one we just dumped from memory, we definitely see a lot more. In fact, we could then take this, we could load it into, we could do memory analysis or malware analysis, we could load it into IDA Pro, reverse engineer it, and so on, and we could probably see it pretty clearly. This is the way that I use Volatility most of the time. It's actually faster for me to load up some malware in memory and dump memory and do this to get an unpacked copy than to sit there and try to go through and manually unpack it. There are pieces of malware and there are packers which are smart enough where they basically only unpack the next couple instructions ahead of it. So doing it in this method won't get you a totally unpacked copy, but sometimes you're not looking for that. Sometimes you want to dump strings and you want to see its configuration file, which you can pull that way. You want to see where it's connecting out to and so on. So that's what I have on Volatility. I actually went a lot longer than I expected to. I apologize. Do you guys have any questions on this? Yes? It's a good question. I want to say yes. And, oops. Let me just grab for a timeline. So the question was, does Volatility have anything that'll do timeline analysis? Yeah, so there's one called Timeliner, which creates a timeline from various artifacts. I'll be honest with you, I have no clue what this does or how it works, so let's see what happens. So it's basically pulling out sockets. It's pulling out, it'll probably pull out it pulls out processes, when they started, probably when they exited. It'll probably pull out registry files, threads. So yeah, so you could, if you had this on a system, you also had the disk timeline. You could implement this into a timeline. All right, so there's another tool called, I think it's called Plazo, which is like the super timeline tool. It can basically take timelines from about 100 different types of logs. I want to say that it can take this as well. So you just create the super timeline that includes everything that was happening in memory as well. So, anybody else? Any other questions? Yes.
So, want to play with it, I've heard of it before, but if it comes down to true forensics, then I'm going to have somebody who's a true expert. Right? So that's the disclaimer, because especially if you're getting into legal territory.
Oh, absolutely.
If you're just doing a technical response or learning what you need to be responding to, you're fine. But if you don't have to hold up to litigation or cross-examination.
Well, and that's one of the first questions that we ask and answer in an incident is, do we think this is going to end up in court? We actually have a master services agreement with an outside firm. We're using but we did that because when you have an incident, it's not the time to be negotiating with somebody who has that expertise.
Exactly. Oh, absolutely.
Ask me how I know.
No, I 100% agree with that. What I will say, though, is I've seen instances, and I've been in instances where I've been on the corporate side where we do have something like this happen, and we have contracted out to somebody, but they can't get to us in a certain amount of time, so they'll ask us to dump memory for them to save that information. Because, like I said, this is memory, this is volatile information. It's constantly changing, so the sooner you can get it, the better. And then, if you're able to get it, then, if you're able to understand at least how to look for some things, the more information you can give the responders, the better too. It'll help direct them as well. Yes?
So in real life, in your real job, how often do you see a rootkit? Is that like a daily, weekly, monthly?
And I don't see true rootkits very often. So when I say a true rootkit, I mean a malware whose sole purpose is to be that rootkit is to hide stuff on the system. I see, more often than not, you're going to see the rootkit capabilities built into a piece of malware. So somebody's going to take Zeus, which has its source code out there. Anybody can take and compile and do whatever they want. Have like a Zeus bot with rootkit capabilities built into it. That being said, most of the time, or how often do I see that? Not very often, honestly. I actually was out at a security company's doing some training for them. I was training their malware analysis guys a couple weeks ago, and I asked them that question too. And they said, honestly, we don't see true rootkits that very often as well. So I would say I'm seeing probably about 25 to 30% of the malware have some type of rootkit capabilities in it, but usually it's not very sophisticated. Very rarely do you get like the bootkit type malware that will hide itself in the file system tables and things like that. Those are out there, and there are ways to find them. In fact, with Volatility, you can actually dump the MBR and analyze it. So there are ways to do that. I don't see it that often.
So speaking of malware, did anybody else hear about the creator of the black hole exploit
Getting arrested?
When the update stopped, they were pretty sure it was him. Well, he's definitely in the pride.
Probably. It is Eastern Europe. Yeah, I would say it's very easy. If you don't want to, go through the whole thing, if you're not comfortable with Linux and you're not comfortable with the command line,